When I was your age, I had lots of questions. I used to question almost everything I saw. I saw the sky, I asked why the sky is blue. I saw the rain, I asked why the rain falls down. Why some drops of rain are bigger, why some are smaller, why some drops of rain are falling faster, why some are falling slower, why, like, how does the wind affect the rain, and lots of these kind of questions. And I'm pretty sure you also ask these kind of questions to your elders, to your parents, to your teachers, and you want the answer to them. When you are asking question, you are a curious learner. And when you are a curious learner, you are a scientific learner. So let's start today's video. Welcome to Mero School. I am Vivek Lal Karna. So before starting anything, I request you to sit properly in a straight posture like me right now. And let's dive into today's video. So in today's video, we're going to actually talk about these kind of questions and a proper method by which we can find answers to these questions. For example, we can have a question like, why did the apple fall? Right? You can have a question like, how fast does the apple fall? You can have another question like, if everything falls down, why does not the moon fall down? Right? So all of these are very interesting questions that you can ask and you can look for. You can have other questions. How does the speaker make sound? Or why do I hear dimmer sound when the speaker is far? Right? And when I'm closer to the speaker, I hear a louder sound. Why does that happen? Or what happens when I put the speaker very, very far? You stop listening to any sound, right? So why does that happen? Right? Because the sound is still being produced. Why am I not listening anything? So what is the proper way to answer these questions? Or what is the proper way that we can investigate these questions scientifically? Okay. So these kind of methods fall under scientific learning method. Scientific learning method is defined as, see, it first of all begins with curiosity that develops after observation. You saw something, you are interested in it, you asked a proper question. That is how scientific learning begins, right? Scientific learning begins with curiosity. You need to be curious to be a scientific learner. And the next topic is the systematic study to find the answer of such question is scientific learning process. So there is a systematic study to find the answer of such questions. Systematic means literally it is something procedural. Procedural again meaning it is something step by step. You follow one step, you go to next step, then you go to next step, and this is how you find the answer to some question. What are those steps? We will discuss about them in the upcoming slides or upcoming minutes. But before that, what is required and what is involved in scientific learning? Let's see that. So scientific learning involves deep thinking, it involves searching the reason, and it involves finding the solution by that systematic study, by that systematic process. So what are those procedural skills that we need to have? What is the procedure? What is the step by step procedure to actually find the answer to those questions? So let's dive into that. First of all, these procedures start with one thing. We have talked about it. That one thing is observation and curiosity. So the first thing that you need to have is observation, and then you need to be curious to ask some interesting questions about it. For example, you're walking on the road and suppose you saw an apple fall. See, like this. And you asked a very interesting question like, why does the apple fall? Or you can ask a question like, how fast does it fall? These are very interesting questions, right? These are the questions that we saw in the beginning and we are seeing them again. So these are interesting questions. So now you see, we have already seen two steps of this scientific learning process. The first step, the first procedure is observation. You observe something, and if you are curious about it, you must ask some interesting questions about it. And those questions can be, why does the apple fall down? How fast does it fall? So all of these kind of question. Then the next step is hypothesis. In hypothesis, we basically guess what must be the process behind it, what must be the actual reasoning behind it. So hypothesis part is just guessing. but it should be some logical guess. It could not be anything random. So for the question that we actually saw over here, let's talk about the second question. How fast does it fall? And maybe our guess is it falls faster and faster every second. We might not know exactly how fast, but we know that it is getting faster and faster every second. Okay, so this is our hypothesis. Now we are going to test it using our next steps. So see, 3 steps are in: observe, question, and hypothesize, or give a hypothesis, give a logical guess. Then we have experiment. You have to now design a very well-defined experiment just to test your hypothesis. Whatever you have guessed, you have to test that now, right? So that falls under experiment. And suppose you design an experiment like this. You are going to drop the apple, but you are going to record it. So that's why you got a video camera. Now you can also record on your phone, so you don't need a video camera for that. And you got a scale like this. Okay, this scale could be a meter stick, which is very big, and you can hang it on the wall or something at the background, so that you can see at different moments of time how fast is this apple falling and where is this apple. So that will be our observation part or analysis part that is coming after this. But this is the experimental setup. I guess this is proper, right? This is totally okay for our hypothesis. We are just going to see how fast does it fall, right? And our guess was that it falls faster and faster every second. So we are going to check that guess using this experiment. Okay, very good. Our next step is analysis. Now we dropped the apple. We recorded the whole apple falling down. So you must also be very careful not to move the camera, because when the camera moves, the even scales over here will be up and down in the frame. That's why keep your camera steady. You can get a tripod or put it on the table. So get it steady. And now when you record the video, and now what you have to do is slow it down. Like almost every phone has that kind of capability these days, that you can edit the video and slow it down. Slow it down to 25%, slow it down to 10%, right? And after that, observe what is actually going on and take some data. So suppose you are picking up data every 1 second, every 2 seconds, like that. In the slow version, it might be a bit bigger. So suppose you are taking the data every 0.1 second or every 0.5 second. You can do that. I'll actually ask you to do this with the help of some elders. It is very interesting. And take the data at 0.1 second or 0.5 seconds. Suppose it was at 10 centimeter. Let's imagine. At 1 second, it was at 20 centimeter. Let's imagine. But at 1.5, now it went up to 40 centimeter. At 2, it went up to suppose 60 centimeter or more than that. So all of these should be recorded on a chart, and then you analyze the data. That is this part, analysis part. You conducted the experiment, but it was not just to look at, right? You have to perform some calculation and see whether your hypothesis is actually correct or not. So that's why we're going to analyze our data. Okay, great. So we analyze the data, and what you will find is that the apple actually goes faster and faster every second, like in this image over here. If you see, in the first part of time, it was here, then it was here. See, this distance is increasing. That means it is getting faster and faster every second. So you conclude that by writing that in conclusion. Then after that, we have reporting. See, whenever you conduct an experiment to check something, then what you do is you report it. You write whatever you have done from beginning to the conclusion part, everything. You write it down, and then you submit it to some elders, some teachers or professors, whoever are teaching you, right? Or just publish it out in the world. So you have to do this so that now you have conducted the experiment, but science works on repetition. Your experiment must be repeated by someone else, so that to confirm that whatever you have got is actually correct, right? That's why we do all of these processes over here. So in report writing, you write the procedure of what you did, you write how you analyze the data, you write what kind of experiment was this, you write what question were you trying to find the answer of, everything, right? So I guess you are now pretty much interested in how to write this report, because report seems to be the main part of what am I doing and how am I going to record it so that other people can like perform the same experiment and validate my results, right? So this part is interesting and we are going to talk about it in upcoming videos. For now, let's check whether you are paying attention or not. It's quiz time. So if you come over here, we have a quiz. And there are 5 questions, 5 MCQ questions, multiple choice questions. You have to find answer, which is basically one option over here. For example, in the first question, we have which of the following is very important for scientific learning? So is it hunger? No. Is it curiosity? It seems. Is it laziness? No. Is it knowledge? No. We perform this whole scientific learning process to gain knowledge. So that means curiosity is the most important thing. You must be curious to actually go through this whole endeavor and do all of these steps to find the answer of some questions, right? So I did this one question for you and I hope you solved all of these questions, and just pause the video over here, copy these questions and try to solve these and show it to your teacher, show it to your elders, your parents, and then resume again. Okay, so I hope you actually paused the video and solved all of this. If you did that, congratulations, you are actually a scientific learner. Now, if you didn't have anyone to actually show these answers to, I have the answer for you. These are the answers over here. Check whether you did it correctly or not. If you did all of them correctly, then congratulations again. Now let's actually move on to the interesting part that is coming in the next video. Like, how do we write a report? And these were basic practical works. What are other practical works in science? If you want to know the answers of these questions, then we'll actually try to answer that in the next video.